Kumar, and we are going to discuss exponent and index. In this, we are going to learn use of exponent to express a small number in a standard form, or use of exponents to express a very large number in a standard form. In previous class, we have learned to express a large number in standard form. And now we are going to simply revise those previous chapter. In class 7 you have already studied that standard form of any number like 318650000 is 3.1865 into 10 to the power 9. Another example, see a standard form of 0.0000753 is 753 by 1 and the 80 equals to 753 by 10 to the power 8 equals to 7.53 by 10 to the power 6 equals to 7.53 into 10 to the power minus 6. Next is very small number can also be expressed in standard form using the negative exponent, as already we show you in this slide. And after that, a very large number or a very small number can easily be compared with the help of exponent after changing them into the standard forms. Now see here, we are going to discuss some problems related to the same topic. That see here, that is a value in 1500000, and there is a 6th place value between the decimal points and the 1. And for that, we have to now change the decimal value to the between the first and second digit of the number. And now we are going to move the decimal to 1.500000. After that, we have to eliminate any zero left at the in number, and we write down 1.5. There are 6 place value between the decimal points and the 1. So the exponent is 10 to the power 6. That gives result 1.5 into 10 to the power 6. See another example to express a very small number into the exponents. See here, suppose that we have a number is 0.000325. See here, between the decimal point and the 3 there are 4 spaces, 0, 0, 0, 3. Now for that we have to now move the decimal point to 3 to make it 3.25. Move the decimal point to the right for the first non-zero number. First non-zero number is what? 3. So we move the decimal point just after the first non-zero number. After that, 4 spaces between the decimal point and 3. So now we have to count how much digit we are moved. We have to count that, and that is 4 digit. So the exponent is 10 to the power 4. Now see here, 10 to the power 4 is in negative because this is a negative exponent. So we have to write down 10 to the power minus 4. After that, we are going to write down the answer is 3.25 into 10 to the power 4. Type 1. Problems based on writing numbers given in usual form in standard form. See here how we are going to discuss it, because we have already discussed some problem. So I think you have an idea now how to do that, and there are some working rule by which we are easily understand to transfer any normal number into the standard form. And for this you have to follow some basic rules. So rule 1 is writing a number in a standard form or scientific symbols means writing the number in the form of k into 10 to the power n, where k is greater than 1 and smaller than 10, and n is an integer. Here, second rule, if the number is 10 or greater than 10, then shift the decimal to our left so that only one digit occurs before the decimal. The value of n will be equal to the number of places decimal is to be moved to our left, and it will be a positive number. It is usually used in the large number when we have to change the large number into a standard form, then we have to follow this rule. Again, next is, if the number is greater than or equal to 1 and less than 10, then n will be 0. If already number is between the 1 and 10, then n will be 0. Third is, if the number is less than 1, then decimal will have to be shifted toward right and the value of n will be equal to the number of places the decimal is to be shifted toward right with negative sign. Now, if this rule is work when the number is very less and we have to transfer the smaller number into the standard form, and for that we have to shift the decimal towards the right, and then we are able to do that. And in very small number, exponent is always negative. Thus, if decimal is to be shifted 5 places toward right, then n is equals to minus 5. See one more example, decimal into a scientific notation. First we have to do what? We have to move the decimal point right or left to arrange one digit to the left of decimal point according to our problems. Suppose, like, see first example, 52,314. Now we have to change the decimal from right to left. By how many places? By 4 places. Because if any number is 52,314, then we can write down 52314.0. So decimal is where? Decimal is after 4. So we have to shift the decimal after 4 digit between 5 and 2. That's why we have to write down 10 to the power 4 into 5.2314. See next example, 3.2. 3.2, we already see here that 3.2 lies between how much? 1 and 10. 3.2 lies between 1 and 10. So we don't have to do anything. Just we have to multiply it by 10 to the power, that is already 1. Now changing the smaller digit. See here example 0.0000428. Now we have to shift the decimal until the non-digit. We have to find the non-digit number. So we are going to shift the decimal up to how much? Up to 4. Up between 4 and 2. 4 is the first non-digit number. So we are going to write down 4.28. Now we have to count how much digit we shifted. So see here 0.00004. It means how many digit? 5 digit we are shifting. So we have to write down 10 to the power minus 5. See another example, very large number, 602 billion. We have to change it into a scientific notation or a standard notation. See here, 602 billion can be written as 6.02. And how much digit decimal is shifted? 3 plus 3 plus 2. 3, 3, 6, 7, 8. So we have to write down 10 into 10 to the power 8. Type 2. Problems based on writing numbers given in a standard format, usual form. Until now, we learn how to change any small number or large number into a standard form. Now we are going to discuss how we are going to change a standard form into a usual form. And how we are going to do that? See here, suppose example 4.12353 into 10 to the power 7. First we have to remove the decimal, and for removing the decimal we have to write down 10,000 below 41253. So we are going to write down 10000. Again we have to multiply 10 to the power 7. So we are going to write 10 to the power 7. Now 10,000 can be written as 10 to the power 4. So we have getting the result 41253 by 10 to the power 4 into 10 to the power 7. Now denominator is containing 10 to the power 4 and numerator is 10 to the power 7. So we are going to subtract the 10 to the power 7 minus 4. Remember the rule of exponent, where we are going to write down a to the power m by b to the power n equals to I am repeating again, a to the power m by a to the power n equals to a to the power m minus n. Remember that formula. We are going to apply that and we get the result 41253 0 0 0 because 10 to the power 3 left, so we have the digit in usual form is 41253 0 0 0. Another example we are going to discuss, that is 0 point, there is a 13 0 and 85. This is a very small digit, and now we have to change it into what? Into the standard form or scientific notation. So we can write down 85 by 10 to the power 13, that is equals to we have to change 85 it into a decimal, so we have to write down 8.5 into 10 into 10 to the power minus 13 equals to 8.5 into 10 to the power minus 12. See another example, a very small number 14 0 and after that 942, decimal 14 0 942. So we can write down 942 as a 942 by 10 to the power 14. Now we have to change 942 into a decimal also, so we are going to write down 9.42, and again we have to, when we are shifting the decimal, then we have to write down 10 to the power 2 because we shifted 2 digit toward our left hand. So we are going to write down the 9.42 into 10 to the power 2 by 10 to the power 14. Now again use the formula previously discussed and 9.42 into 10 to the power 2 into 10 to the power minus 4. Now this is added 2 plus minus 14. We get 10 to the power minus 12 into 9.42 answer. See another problem, 602 into 10 to the power 13. We have to change it into a standard form, and in a standard form, for a standard form we have to show the decimal value. So we are going to change 602 into decimal, that is 6.02, and for that we have to multiply 10 to the power 2 into 10 to the power 13 equals to 6.02 into 10 to the power 15. Again see another 837 by 10 to the power 11. Now 837 is changed into a decimal, so we have to multiply 10 to the power 2 by 10 to the power 11 equals to 8.37 into 10 to the power 2 into 10 to the power minus 11 equals to 10 to the power 2 plus minus 11 equals to 8.37 into 10 to the power minus 9. This is very simple, and after seeing those step by step solving process, you can easily learn how we have to do that. See another is 3186 into 10 to the power 7. We have to change it to a scientific, and for that we have to write down the decimal before the first non-zero number. First non-zero number is 3, so we have to write down 3.186 into 10 to the power 3 into 10 to the power 7 equals to 3.186 into 10 to the power 3 plus 7 equals to 3.86 into 10 to the power 10. Type 3 problems based on adding, subtracting and comparing a very large or a very small number. Working rule: write the given number in standard form. First we have to change either a smaller or greater number into a standard form. When we change it into a standard form, then write the number written in a standard form as number containing same power of 10. Now the number can be easily added, subtracted or compared. When we change any number as either small or large into a standard form, then we just have to compare the exponent and we can get the answer easily. See here, a standard form is a shorthand way of writing a very small number. It is written as a number between 1 and 10 but not equal to 10 multiplied by a power of 10. For example, 2.94 into 10 to the power 2 or 4.8 into 10 to the power minus 3. In this worksheet, we must compare such number. Suppose that we have to compare 583 0000 equals to 5.83 into 10 to the power 6 and 11223392 can be written as 1.1223392 into 10 power 7. So now we are going to, now third number is 694000000 equals to 6.94 into 10 to the power 8. Now see here, these numbers are in increasing order between 10 to the power 6 number are always smaller than 10 to the power 7 number etc. So 5.83 into 10 to the power 6 is always less than 1.1223392 into 10 to the power 7. So now see here, we are easily able to compare any number when we are going to change that number into a standard form of scientific notation. See another example. The distance between Sun and Earth is 1.496 into 10 to the power 11 meter, and the distance between Earth and Moon is 1492.16 into 10 to the power 8 meter. During solar eclipse, Moon comes in between Earth and Sun. At that time, what is the distance between Moon and Sun? Here, distance between Sun and Moon at solar eclipse is equals to 1.496 into 10 to the power 11 minus 1492.16 into 10 to the power 8. We have to change both of the number into a standard form, and for that we can write down 1496 into 10 to the power 8 minus 1492.16 into 10 to the power 8. We take a 10 to the power 8 common, and then we get the result. The difference, that is 3.84. So our answer is 3.84 into 10 to the power 8. Thank you.